Today we're basically going to take everything we've learned about the unit circle so far and apply it to the unit circle and label a unit circle correctly. So now that we've learned about the degree measures in the unit circle, the points on the unit circle, and now that we also know about radians, we can label every part of the unit circle that we're going to need to know. And you're actually going to use the unit circle a lot in pre-calc next year and in calculus, whether or not you take calculus in high school or you take it in college. So we're going to follow the directions. And before we really get started though, this is the same worksheet as your assignment. I'm just making a video to help you get started on the assignment, to kind of like point you in the right direction. So as you'll notice in the blank notes folder, there is not a copy of the notes for this video because it matches what is already in the assignment. So the directions are to place the degree angle measure of each angle in the ovals inside the circle and the radian measure of each angle in the box. Place the coordinates of each point in the ordered pairs outside of the circle. So let's jump right in. So we're going to put the degree measure in the ovals, the radian in the boxes, and then obviously the points and the coordinate points. So for the unit circle, we already know the 4 main points off the top of our heads. We know that this point here, because the unit circle does have radius 1, so this point will always be 1, 0. The point on the positive y-axis up here will always be 0, 1. Then on the negative x-axis, it'll be negative 1, 0. And then on the negative y-axis, it'll be 0, negative 1. So I'm going to help you fill in the first quadrant today, and then for your assignment, you're going to fill in the other 3 quadrants. So what's nice is, I believe last week, we already filled out most of the unit circle. So you should actually already have all of the points, all of the degrees. The only thing you're missing are the radians. So that's what we're going to add today. So I know that at this part of the unit circle right here, that this is 0 degrees. And it's also 360 degrees. So if we go all the way around the circle, this x-axis also represents 360 degree rotation. So if we convert 0 degrees to radians, remember for our conversion for degrees to radians, we take our degrees and we multiply them by pi radians over 180 degrees. So if I'm converting 0 degrees to radians, we're going to get 0 radians, right? Because isn't 0 degrees times anything just going to be 0? So I know that this is 0 radians, but I also know that because this is not only 0 degrees, it's also 360 degrees, I need to take 360 degrees and multiply that by my conversion of pi radians over 180 degrees. And 360 divided by 180 is 2, and then degrees divided by degrees cancels, and then 2 times pi radians is just 2 pi. So this is also 2 pi. All right. Then if I went all the way up here to the y-axis, that degree rotation would be a total of 90 degrees, or 1/4 of our circle, a quarter of the 360 degrees. So 90 degrees as radians. So we can either use our conversion, obviously, or we can use some common sense. So isn't 180 degrees half of the circle? If the whole circle was 2 pi, wouldn't half of the circle be just pi? Well, if half of the circle is pi, then another half of that, or 1/4 of that, would be pi over 2, because you would just divide it in half. Let's see if we're right. So let's take 90 degrees and multiply it by pi radians over, I almost wrote 360, that should be 180. 90 goes into 180 twice, that becomes 1. 1 times pi is pi. 2 times this would be technically over 1, so 1 times 2 would be 2. Pi over 2 radians. Yeah, which is what we figured out. If this is all pi, this would have to be half pi. Okay. So then halfway between 0 degrees and 90 degrees is 45 degrees. And then these two then divide the quadrant here into thirds. So a third of 90 is 30 degrees, and then 2/3 of 90 would be 60 degrees. Again, these angle measures we figured out last week. We also figured out what these points would be, the coordinates of these 3 points. So I'm just going to look at my work from last week to label those points. So let's get our notes from last week. I'm just pulling those up for myself real quick. And let's get those points labeled. So we figured out that the x-coordinate of the point at the 60-degree intersection of the unit circle, the x value was 1/2, the y value was √3/2. We figured out that the point of intersection for the 45-degree angle was at 1. Why is that up there? Okay, there we go. Was at √2/2 and √2/2, because those should be the same. And then we also figured out that the point of intersection at the 30-degree angle was √3/2 and 1/2. All right. Now we just need to fill in the rest of our radians. So I'm going to convert 30 degrees to radians. So I'm going to erase some of this to make more room for myself. So 30 degrees into radians, I'm going to stop moving. There we go. 30 degrees times pi over 180 degrees. My degrees cancel. 30 goes into 30 once, 30 goes into 180 6 times. So this becomes pi over 6. So 30 degrees is the same thing. Sorry about that. 30 degrees is the same thing as pi over 6. Now let's convert 45 degrees to radians. So 45 degrees times pi over 180 degrees. The degrees cancel. Let's see, 45 goes into 45 once, and then 45 goes into 184 times. So we would be left with pi over 4. So 45 degrees is pi over 4 radians. And then 60 degrees, so there are 2 ways we could figure this out. One is, let's use our conversion. And the second is, well, isn't 60 degrees 2 pi over 6s? Or 2 30 degrees? So if 60 degrees is 30 degrees twice, then isn't 60 degrees also pi over 6 radians twice? So that would just be 2 pi over 6, which is the same thing as pi over 3. Well, let's see if we're right using our conversion. So let's take 60 degrees times pi over 180 degrees. Again, our degrees cancel. 60 goes into 61, 60 goes into 183 times. Check it out. It is pi over 3. All right. So you are in charge of filling out the rest of this unit circle as your homework assignment. Good luck with that. Shoot me an email if you have any questions, and I will see you guys next week.